Right, in this video we're going to be talking about how to calculate the total resistance in a series circuit and a parallel circuit. So a series circuit, current only has one direction to go around, so we can say that it's only one loop. So in this case, there's only one loop which goes from here all the way around. And in the parallel circuit, the current can actually split up into different routes. So the first route is that one, the second route is there. So basically, another way of thinking about this is how many loops there is. So in our parallel circuit, if there's more than one loop, that's a parallel circuit. So to calculate the total resistance in a parallel circuit, it's 1 over R1, if this is R1 over here, and that's R2, plus 1 over R2, plus 1 over R3, and so on. In a series circuit, it's quite simply R1, the resistance value of R1, plus the resistance value of R2. So let's put this into examples so we can see what is happening better. So in a series circuit then, there's one loop, R1 and R2. This one is 10 ohms, this one is 6 ohms, and the total resistance here is going to be 10 plus 6, which is 16 ohms. And in this one, the total resistance, there's three resistors, there's three different loops. So we say 1 over 6, 1 over 1 plus 1 over 4 plus 1 over 2 for that one, because it's a 6 ohm, 4 ohm and 2 ohm resistor. And the total resistance is 1.09 ohms in this one, and the total resistance on this side is 16 ohms. So how is this information useful? Well, you can find out the total current that is going around the circuit. How do you do that? Well, if there's a cell which is rated at 3 volts, for example, and there's a 3 volt cell over here, we can find out how much current is actually going around in the circuit. So what we do is we basically use Ohm's law again. So we're going to say V divided by R this time is equal to I. So in our case, it's going to be 3 divided by the total resistance 16, and that's how much current is actually going through that battery, which is 0.19 amps. So that's the total current. I should put IT there. And in this case over here, it's exactly the same, V over R, which is going to be equal to IT. So in our case, it's 3 divided by 1.09. So the total resistance in this case is 2.75 amps. And of course, in this one, the current will split at this point over here, and then it will split again at this point because it's coming around and it's split basically going forward. Yeah, thank you.